Above our heads, something invisible is moving, fast.
These aren't stars. They're machines, flying in perfect formation. So how does internet come from space? Every second, satellites pass silently over cities like this.
Speeds once impossible, now measured in milliseconds.
Places with no cables suddenly come online.
One dish, no technician, no alignment.
Thousands of satellites are already orbiting Earth.
All connected. Factories, rockets, and a planet-wide system.
This is how Starlink built a global internet web.
It all starts inside a highly controlled facility.
Production begins inside controlled, clean environments. Circuit boards form the brain of each satellite. Robots place components with microscopic precision.
This lightweight frame is built for space, not Earth. Solar panels fold like origami. Antennas are tuned to exact frequencies. Laser systems are aligned to fractions of a millimeter. Satellites face extreme heat and vacuum tests. They're shaken harder than any rocket launch.
Each satellite weighs less than a refrigerator.
Smaller size means faster launches and lower cost.
This is not handcrafted. It's mass production.
Hundreds are built every single week.
Every satellite receives a digital identity.
Quality control catches invisible failures.
Software flags problems long before launch.
Engineers analyze millions of data points.
The final systems are brought together here.
Protective casings lock everything in place.
Each satellite is now fully ready for space.
They're stacked together in a launch-ready configuration.
Dozens fly together on a single mission.
The satellites are moved to the launch site. Now comes the most dangerous part. The rocket stands ready. The payload bay opens.
Inside sits the entire Starlink satellite stack.
Every system is watched in real time.
Fuel begins flowing into the rocket.
The final countdown begins. Engines ignite.
The rocket lifts off. Lifts off.
The ground feels the force beneath it. Within minutes, Earth begins to fall away.
The rocket separates into stages.
The protective fairing opens in orbit.
Satellites release into orbit, one layer at a time. Each one moves into its exact position. Solar panels unfold in space.
The satellites power on for the first time.
A first signal is sent back to Earth.
Ground stations receive the first response. The mission is officially confirmed. But this is only the beginning.
Orbit didn't always look like this.
Then the first satellite appears.
Then hundreds follow the same path.
Soon, those hundreds become thousands.
Together, they form a moving grid around Earth.
Coverage reaches even the polar regions.
Lower orbits mean faster communication.
Traditional satellites sit much farther away.
This reduces delay in data transfer.
Satellites communicate using laser links.
Data moves satellite to satellite in space. There are no cables and no towers.
Coverage extends across open seas. Deserts gain access without new infrastructure.
Mountains no longer block connectivity. In emergencies, connectivity arrives instantly. The network is always in motion. Each satellite can adjust its path.
This prevents collisions in crowded orbits.
Debris is tracked constantly in orbit.
Position of the car.
Navigation decisions happen in real time.
Orbits are adjusted continuously.
At night, the network stays active.
A continuous web surrounds the planet.
This internet never sleeps.
Setup begins with a simple box.
It works even in extreme cold.
Heat doesn't stop the signal. The dish automatically finds its signal.
Connection completes in just minutes. Speeds can accept 200 megabits. Latency stays remarkably low. Online gaming feels smooth and responsive.
Video calls run without noticeable lag.
Remote communities come online instantly.
Connectivity follows people anywhere.
Ships stay connected far from land.
Aircraft now maintain stable connections.
Emergency teams rely on instant data.
Education reaches places once disconnected.
Businesses operate without location limits.
Yes, we can ship that out today.
Users notice the difference almost immediately.
Feedback reflects consistent real-world performance.
Coverage continues to expand worldwide.
So what's the catch? It's a catch.
Low Earth orbit is becoming crowded.
Astronomers are closely monitoring impacts.
Light pollution is a growing concern.
Satellites are designed to deorbit.
They safely burn up in the atmosphere.
New launches replace older hardware.
Each generation becomes more efficient. Laser links continue getting faster. Coverage continues expanding worldwide.
Billions could eventually gain access. The same system could reach Mars.
Launches continue to expand the network. Space itself remains quiet.
the world becomes fully connected. Internet without borders.
The system continues circling Earth.
From orbit, the planet tells one story. Built on Earth, operating in space.
Subscribe to see how the world really works.
The connection keeps moving forward.